Right. I think this time YouTube Studio is telling me that we're live. So good afternoon, everybody. Sorry for the slightly late start. I'm joined today by Petr Viktorin, who's a CPython core developer. We just gave a little bit of an introduction to absolutely nowhere because I'd forgotten to start the stream. So I guess we'll do that again. Petr and I have been communicating over GitHub and a little bit on email exchange too. Regarding that PR that we created a few weeks ago to propose a new way of reading string data that would help Pyo3 get away from CPython internals. And Peter's response to the PR that we built is rightly that what we do is exposing probably the CPython internals in a different way rather than actually coming up with something better. So our goal for this afternoon is to have a bit of a design session and see if we can prototype that something better. So Petr, do you want to go ahead and introduce yourself?
Hello, I'm Petr. You can't see my face, but I think you can hear my voice, hopefully. And yeah, let's see how this goes.
Okay, great. So just as a reminder for everybody on a bit more of the context in detail, we're looking at the PyUnicode type, which is CPython's internal name for what Python calls a stir. And we created a couple of weeks ago 2 new functions, PyUnicode data and PyUnicode getKind, which the intention was to provide. I mean, these functions already exist, but not in a, I guess what's the right way, stable way for Pyo3 to read from it. It's dependent on the implementation details. Petr is slightly quiet. Okay. Thanks for the feedback.
Just start an OBS, so I'll say something and maybe get that to the same audio level. Hello, hello, hello.
You're going to have to bear with me while I first figure out. First time I've tried to. I know that there's a way to set the gain. Here we can.
Probably is something. I don't know how your OBS is set up.
Let's just try. What should we do? 10 decibels? No, that's probably too much.
Well,
5?
I don't know.
Maybe keep speaking. I think I'll.
Okay, I'm speaking. Let's see how this works. It's better, apparently, according to somebody in the chat.
Okay.
Lily. Hello, Lily.
Thanks, Lily. That's good, is it? Okay, we'll leave it at 10 decibels. If that's gone too loud now, we can turn it around again. If it's not loud enough still, we can turn it up again later. Okay, brilliant. Thanks, Lily and David. And good to see you both again this week. Great. So, yeah, these PyUnicode data and PyUnicode getKind, they exist already with slightly different names. I think they've got capitalized names rather than these camel case names which we wrote. But they work by reaching into the internal structure inside of the string objects in the way they currently exist. And so these symbols we added, the goal was to create a way where it's just calling a function and Pyo3 doesn't need to know about the internal structure. But it's still kind of revealing a fair bit of information about the internal structure, right? Like we're reaching in to get wherever the data is from that structure and we're learning what the structure contains. And
so I think the major problem here is that it assumes this data will be available in the Unicode object.
Yeah.
Which is currently the case, but it might not be the case always in CPython.
Yeah. From
certainly other implementations of Python might not do it like that. Of course, the C API is currently for CPython specifically, but looking at other implementations is usually useful for figuring out what CPython might want to do in the future.
Yeah. I think one takeaway that I particularly got from when we were talking off stream was about the idea of like, at the moment, Python isn't storing data in UTF-8, and there are reasons why that's really, really hard, but it's something that people might want to experiment with. And having these kinds of APIs kind of really locks out that option because it makes it harder to experiment with different encodings, right?
Yeah, so about UTF-8, that's kind of a weird case. So Python strings have 2 representations. One is the flexible byte format. So as many bytes as you need for the biggest character in the strings.
which is what these
That's,
kinds are, right? It's the
yeah, just either
different size of the character.
1, 2, or 4 bytes, I think it is,
Hmm.
uh, per character. And then there's the UTF representation, which is computed on demand. So if you ask for it, CPython will allocate memory for it, fill the buffer, and then store it forever on the string until the string itself is deallocated.
Yeah. I can
That
actually try and talk to that a little
makes
bit. We
sense.
can look at the structure, can't we, on in the C source code. So we can see in a Unicode object, well, it's got all this different state that we talked about in the past. And so here we've got some data, for example, which has got these different kinds. It's in a union, so only one of these is populated. And then there's also this UTF-8 representation, which you just mentioned, that gets cached and computed when it's needed.
Right.
But I guess there is still like normally an alternative data format as well, because things like Python indexing depend on these data formats, not on the UTF-8 format, I think.
Yes.
So yeah, it's a bit.
But of course, that could be changed.
Yeah, it's a question for another time, I guess. But the answer is that this particular encoding is not something that CPython necessarily wants to force and like promise the whole ecosystem will live in this way forever. And so having the APIs as we propose them doesn't really make sense. So I guess now's a good time to talk about what we were thinking of doing instead. And there was a pull or a good discussion thread on this. I think what's a good way to name it? Do you think PyResource API is kind of the impression I got? I actually didn't bring this up, but I can try and find it.
Yeah, something like that. So Victor almost wrote a pep about this.
Yeah, let me see if I can find a proposal for it. Yes. Fortunately, Google's been my friend. So I'll switch back to the browser for everyone on YouTube. I think it's this one that I found.
Draft. Yeah.
And so the particular motivation that Victor's writing about in this issue, I think, is also particularly about things like dangling pointers, which are a concern particularly for C, where that PyUnicode get data function that we were just looking at returns just a pointer, and there's nothing to tie that pointer back to the original Unicode object other than just good developer practice. And so part of, I think, what Victor was motivated by here was the idea of being able to have a prior resource concept which ties that pointer back in a way that requires you to deliberately say, okay, I don't need that anymore, and avoid that worry of a dangling pointer as well, right?
In Rust terms, you would need some kind of drop callback, I think it's called, right?
Yes. So
that frees the resource.
yes. So I guess if we look at this structure that's proposed in the C API, I don't know whether we would actually need to know the structure layout in Rust, but we could have a type called PyResource, for example, that would know what it's looking at, and then when it's dropped, it would call this PyResource close method that we've got here proposed. I guess one thing I thought about this particular API proposal, I mean, there's lots of use cases for it. I think that, well, I don't want to go through the whole discussion right now, but just talking about things like reading contents from tuples and lists as well, which is a little bit beyond the just string use case that I think we were going to focus on here. But I guess what we can do, or I was thinking we were going to do on this stream, was try and play around with understanding what the shape of this API might look like, particularly for strings, and see whether we can come up with like a toy prototype, right?
Right. And what I was looking at is the existing buffer protocol.
Okay, yes, which we could jump over as well too.
Where should I share links with you here?
You could drop them in the stream chat, or they might be a little bit delayed. I guess we've got where's our call window? That might be just a touch faster for me to get it. Yes, I think I've gone to the same one. Yeah, I have. Great. Oh, that looks like it's a bit small on stream. Let's make that bigger.
So the buffer protocol exists for, well, it does the same thing as the PyResource, and it has a callback that you can call to say, I'm now done
Mhm.
with this buffer. But it also has a bunch of other metadata.
Yeah.
Uh,
Um,
Length, item size,
Here we
format,
are.
and
Let's see
it
if I
can
can fit those on the screen.
export n-dimensional arrays like from NumPy.
Yes, because I think mentioning NumPy, I think my understanding that this structure came into existence to help have some libraries like NumPy kind of have a standard representation across the ecosystem. Is that right? I don't know the full history, but it felt to me like when I was reading this that it was very motivated by the NumPy use case of like the dimensions of the array.
Well, the complications are definitely on NumPy, but I think the core idea of exposing the buffers
Mhm.
uh, is not really specific to NumPy. So PyBuffer is pretty much the CAPI equivalent of memory view. So any
Yes.
object that manages some piece of memory
Mhm.
should export these PyBuffers so you can treat it as raw memory.
Yeah. Um, yes. Where and the memory view normally is only thought of as a one-dimensional array, right?
Right.
But the data inside, I guess, can be interpreted any way you want, but it treats itself as just a string of bytes that you can read.
Yeah. But not, then if you, for example, read an image using the pillow library,
Mm-hmm.
you can then convert it to a NumPy array. And I think it's done through this PyBuffer interface where it
Mm-hmm. Yeah,
uh, tells the other library what kind of shape the data has.
yeah.
So I was thinking of using this and just not using the extra features.
I
There
guess that
is
works.
API to
Mm-hmm.
just fill in a simple buffer.
And so,
Uh, the
mhm.
one thing that PyBuffer or that PyBuffer isn't currently used for
Mhm.
is exporting multiple buffers from the same object.
Um,
So I would like the API for strings to be you ask for, I don't know, 2 bytes per character, and you get that buffer.
mhm.
But you could also ask for 4 bytes per character and get that buffer.
Yes.
And if that actually matches the underlying representation, then you basically borrow the data.
Mhm.
If it doesn't, you get a newly allocated one and filled in, and
Yes.
and there needs to be some flag that says says it needs to be deallocated again.
I think we could kind of use the machinery we've already got, right? Because the way that the buffer protocol works to have that management is by storing a reference to the object that the buffer's owned by, basically, right?
Yeah,
It's this object field that I've got in the center of the screen here. And so, in the case that you're just describing, where if the string is encoded, say, in 2 byte size form, then this buffer can directly contain that string. And I wonder if for the 4 byte size form, we could just create a new string encoded in a different way and then give that to the buffer. And then the only reference to that copy of the string, if you like, is going to be this one owned by the buffer. So then when it's closed by buffer release, it just gets cleaned up. That might be good enough for a prototype.
that might be good enough. The other approach I was thinking of is if you look at the very end of that list of
Oh, yeah.
there's void pointer internal,
Oh.
uh, where we could put a flag saying whether it needs to be deallocated or not.
Oh, I see. So then we could store metadata. So then we could. The nice thing about doing it this way around is that instead of having to create a whole new string object, which is slightly more complexity than we need, we can just literally allocate a raw memory array, stuff things in there, and then the metadata here could say what needs to be cleaned up.
Yeah.
Mhm. Okay.
So
Yeah.
the buffer API then has two functions: get buffer and release buffer.
Yes.
Uh, and I guess we should only populate release buffer and add extra API functions for getting the buffer, since you need it
Um,
for the format.
how does PyBuffer release work? It takes the buffer. So do we actually need to implement the protocol on strings at all? Like you talk about release buffer, and I think
Well,
what you mean by that is adding it to strings type.
if you use the object, well, yes, we do. We need to implement the buffer release.
Okay. Maybe that will become clearer to me when we do the implementation.
Yeah, it's not really documented on that page, but this one put in the YouTube chat.
Oh, and
That's BF release buffer.
yes, so that's on the string type. Maybe it's easier to go explain that if we jump across to the code. So let's switch windows again, go back to looking at the source code. So if what we're talking about now in BF release buffer is we go to C file, then somewhere in this file, this is the definition here of the string type as it's defined in the C API. And there's lots of these so-called things called slots, right, which define different standard functionality, such as repr, or how to be interpret a string as a number or a sequence, or all these kinds of things, hash, or how to convert a string to a string with stir. And I guess one of these is going to be buffer, yeah, this one, which is currently empty. But if we jump up to a PyType object and go look at the TP as buffer section, particularly, it has this BF release buffer slot, which is so I'm going to forget the exact detail as to when that's called. I think I have seen this thing before, but
So that's the drop function for the buffer. So if you
okay,
call what's the name?
it was PyBuffer
PyBuffer
release.
release.
Does it just forward to the slot? Is that
Yeah,
why?
it forwards to the slot of the object that's stored on the buffer.
Yeah. Okay, so that's how the implementation's done. So we'd have to, if we go through the buffer protocol, we have to do that. I guess we can start by trying that this afternoon and see what effect we end up with. Okay, so maybe we'll start by going back to the header file and filling out some definitions.
I mean, I guess we could start by just implementing the bf get buffer.
Okay, go back to the implementation.
Setting up the buffer with the correct item size.
Oh, I see. So we'll do two new methods here in the C file, not add any APIs to the header at all for the moment, and see what happens.
Yeah.
Okay. So I guess are these ordered nicely? Doesn't really look like they are. I'm going to go for that. There's not a particular convention on where to place things in this file.
If there is a convention, I don't know about it.
Okay. Well, in which case, let's... Oh, the only constraint is that we're going to have to put it before Unicode type.
Yeah.
So I guess let's just put them... Oh, we've got some forward...
Yeah, so there's the doc string right in front of that. I maybe put it a bit more up.
A bit higher, okay.
Then there's exact deal alloc that, so below that is fine.
Okay, we'll go in here. Right. So we're going to need to go back and get one of those PyBuffer procs. And this we just write as a static right here.
Yeah. So get buffer proc. What that actually is probably best viewed in the docs.
I'm going to have to refresh my memory on the way things go. Yep. So it's static, disordering, Unicode, buffer prop, or, well, actually the naming was Unicode as buffer, so let's keep to that. And then, I guess...
And then you need two functions, and that would be
Oh, yeah.
Unicode get buffer and Unicode release buffer. You need to implement those.
Yeah, and we don't pass the names, we just pass the
Yeah,
fields.
there's the in the new C standard that we're now allowed to use, you can do .bf get buffer equal function.
So is that the preferred way?
That is now the preferred way, yes.
Let's do the preferred way then.
If you want to, you can convert the whole Unicode type declaration below to that and get rid of all the zeros.
Yeah, sure.
And just grunt work. Don't do that.
We'll do that later, maybe. Okay. And I'm guessing we can't intermix it, can we? We can't just name one field.
I probably need to put it at the end, so don't.
Yeah, okay. Oh, because it will mess up ordering of the positional stuff. Yeah, that makes sense. Okay, so this is now
Unicode as buffer.
Yeah. A reference to our methods we're going to yet define. And then I guess we need to put
and you should name that so this will be private to the file. It'll be a static function as well, so just name it Unicodes.
Like that?
Buffer.
We tend to do underscores without
the underscore.
Yes, like this. I think I've seen a few of these around.
We don't always follow that convention either, but I guess this is the most common one.
Okay, and then we need to put these just above. And so we'll need to go look at the definitions of these. So get buffer proc takes it'll be the Unicode object. It takes a PyBuffer structure that it's going to fill and an integer, which I think is flags, and we can worry about in a little bit. I mean, we probably won't use flags, right? Because we actually don't intend to implement get buffer in the end, maybe. So we can sort of stay away from that.
Flags should be passed to a helper afterwards. Anyway, just copy this line.
Okay. I guess that's not a bad way to do it.
And put static in front of it.
So static int, and instead of this, we need get buffer. And actually, it doesn't have. Oh no, it does have a return value. Probably that's just whether it errored, right? So probably at the moment this is best because we haven't actually filled it in yet. And then that doesn't have any body yet. We need to name the function though. I'm just going to go adjust the blind at my window because I'm getting a bit of sun directly in my eyes. That's a bit better. I can just see the screen without squinting. It's going to give me a bit of eye pain, I think, if I kept that up for another hour and a half. Cool. So, and in these methods then, so we don't create the PyBuffer structure here, right? That's going to come in. And so, we need to give this a name.
Yeah, we don't create it. We get it and we fill it.
So let's jump back to look at this thing. We need to fill in the...
So it's better if you look at the documentation.
Okay. I'll switch back to the browser then for viewers on screen. Okay. Cool. Where are we looking?
BF get buffer.
Oh, okay. Right, I'll need to go to the...
Yeah, I posted a link to the chat. Maybe you can already see it.
Oh, Okay.
It's not on this page.
Text coding glass. Text could be just a little bit bigger on stream. Are you talking about browser or code? Maybe code.
That was a while ago. I think
Oh,
you
okay.
fixed it in the meanwhile. Hopefully it was fine.
All right. If the text size does need changing coding glass, just give me a heads up as to whether it's browser or code that needs changing, and I can adjust. This browser tab I know is a bit small, but this one should be better. Maybe we'll go one bigger just in case. So I think it's going to be in here that we'll find bf get buffer.
Yeah.
Yeah. Okay. Here we are. So the signature of this function is integer, the exporter, which is the object that's going to share the buffer view that we're going to populate, and the flags. We handle a request to exporter to fill in view as specified by the flags. An implementation of this function must take these steps. Check if the request can be met. If not, raise buffer. Okay, so in the case of an error, we should do that. But I think in this case, we don't expect anything to fail, so we don't need to worry about that.
So this is a typical case of read all the instructions first before thinking about it. So yeah, there are some steps to do. There are some more steps to do. Everything's described, and then it says PyBuffer fill info provides an easy way of exposing simple bytes buffer.
Oh, okay.
So I think that will check if the request can be met and fill in the fields for you. And probably won't do it the internal counter. Yeah, but it will do most of the steps.
And I don't think we necessarily need an internal counter here anyway, so that seems okay.
Right.
And looking at this signature, I guess this is also just for one-dimensional data. So that seems fine. Great, so let's go use this then. I'll just copy that straight into the code. Great, yeah, so I was just reading this last sentence. So if this function is used as part of getBuff, exporter must be set to the exporting object and flags must be passed on modified. So that's okay. Right, back to code. So we can call that here. And oh, well, actually the name that seems to be preferred everywhere else is view. So let's use view again here. It's used exporter in other places, but I think Unicode probably fits better here. Unless you have a strong opinion, I'll use Unicode.
Sounds good.
And so this is going to be, it's just going to be the data, right?
Right.
Which we can use. It's just PyUnicode data, isn't it? And I don't know, we need to think obviously about the encoding.
So I think this will set the. I think the fill info will set the item size to 1. And and then there's the len, which is the number of bytes. Yes, so we need to set the length. Yeah, maybe our buffer is too complex to fill with the fill info. But
yeah, because the length. Is there even a convenient way to get the bytes length? Or I guess we need to work out the item size, and then we can multiply through.
The length will be the get length times the number of bytes per character.
Because so this get length is in characters, is it?
Yes.
Number of code points in the string. Great. Yeah. Okay. Cool. So I mean, I still don't totally see the harm in using fill info and then correcting the item size later, but maybe it sort of breaks the encapsulation of the helper a little bit to do that.
I I'm not sure what happens to the shape,
I guess we
but
could
yeah,
try and jump
let's
in.
worry about that later.
It sets shape to null, dimensions to 1,
Oh shit, that's fine. That's great then.
item size to 1, strides and sub offsets internal. It's sort of okay. I mean, there's the flags about writable, which is a good thing. Where strings are obviously not writable objects.
Right.
And it checks for null for the buffer being passed in. Seems okay. We can use this for now. So the item size, that's going to be the most fiddly bit because we've got PyUnicode get kind to do that, but I don't think that is that actually.
Yeah. I think you'll need a switch from that.
Yes, because, well, I was wondering is whether the constants already happen to be the sizes in bytes or whether there's something else. My IDE is not happily finding that one. Oh, I think it might just be called underscore kind. There we are.
So
Okay.
I think they do actually correspond to the number of bytes.
Yeah, here they are. Which is convenient. Do you think it's a bit risky for us to rely on that?
I think so. I mean, if the thing I'm dreaming of happens and we get a UTF-8 backed string object that maybe materializes one of these on demand,
Yeah.
then there would be no good value for for this.
Yes.
So just to be safe, I mean, if this happens, somebody will have to read through every line of the implementation anyway. But I think a switch will be
Yeah.
cleaner.
So we can do it like this, right? We can have in item size, and then we switch on a kind case, and then oh, the kinds even, yeah, they're named 1 byte kind, 2 byte kind, 4 byte kind. Still, seems better. So now we can just fill in item size it was 1, and it's break, right? We have to do that after each switch statement. Okay.
And I hope the compiler will just optimize this to nothing.
Because it will basically see, oh, 1 means 1, 2 means 2, 3 means 3, 4, or 4 means 4. I mean, yeah, it feels like something that should be very doable. Do we need to handle invalid values in this switch?
Yes.
Yes.
So I mean, if we're already writing this out, yeah.
Something like that.
Nice
Copilot wanted to use that.
-1. So -1 is the usual return code for errors, but it always helps to check the documentation. In this case, yes, you should return -1.
Okay, brilliant.
And set views object to null.
Yeah. So this is going to be a bit of a C style question here, and I don't know whether this is good or bad, right? So I've seen in other places in the CPython code base that when there's like an error condition like that, which you have to clean up properly, sometimes there's a like go to error statement or something, and then there's an error kind of section at the bottom of the function. And I've heard other horror stories about, like, I don't know if you've heard of like the go to fail sort of security meme or whatever it is. I can't remember the full details of it, but like as a Rust programmer, we're always taught like goto is bad. And like, so I guess my question to you here is, should we be trying to use goto here to like clean this up elegantly, or should we just go
So
with,
you're not allocating any objects, or you're not taking new references to any objects, so there's nothing to clean up really. So there's no
well,
reason to use goto.
I guess all I was thinking
But
is this is the
I mean,
cleanup, right? That we have to set this.
oh right, yeah.
There's
Oh,
this
that,
one,
yeah.
literally one
So
line
do
here.
that at the very beginning of the function.
Oh, that's smart. And then it's tiny bit less optimal, but it guarantees that whatever we do
I mean,
afterwards, we're
if you
safe.
have a good enough compiler, that it'll notice. Uh, it'll notice what's happening. Hopefully.
Yeah, because it'll see in these paths down here that we assign it, and then it will be able to relocate that into this point. Yeah, that makes sense. Okay.
Anyway, the goto is kind of like Rust's question mark thingy.
Yes. A bit. I know what you mean. Maybe
It hides a
don't.
lot of magic. Yes.
Yes, it's just hiding return. You can expand. You could write a macro expansion for the question mark reasonably
It's
straightforwardly.
hiding a return, but the return is hiding an end of scope, which drops every local variable,
Yes.
which in C you have to do explicitly.
In C, you have to do explicitly, and in Python, you don't notice it at all, right? Because the exception just flies right past your face.
Yes.
Okay, great. Cool. Okay, so I think we've got the item size, and then we said that the next thing we needed to do is we need the length. Now, is that going to be
So
S size
that's,
T?
so you can do that directly in the call, just times the item size.
Okay,
Or
so I'm going to have to ask here about like overflows and things like this, right? Because there are rules in C about
right.
what types you get from a multiplication, which I think I know that there are rules that I don't understand, and so I want to make sure we
yes,
don't get wrong here.
So the length is the number of characters or code points.
Mm-hmm.
The item size is the size of one code point.
Yeah.
Which means that if you multiply them together, you have to get the length of an allocated memory block.
Yeah.
And the nice thing about size is that any allocated memory block has to fit in that type.
Yeah. And
right?
so because
So
we're
that's
using, I'm assuming that PyUnicode get length is going to expand eventually to a PyS size T. Yeah. And so because we're multiplying a PyS size T by an int, then I'm guessing that because this is the bigger type, the whole multiplication uses that bigger type, and so we're safe.
Yeah.
Yeah, because I know I can't remember the details for it, but isn't there rules like if you multiply two 8-bit integers together, you end up with a 32-bit if you're not deliberate or stuff like that. I don't remember the rules on it.
Yeah, I think you end up with a larger of the two types, not anything bigger than that.
Okay, fair enough. Okay, that's quite reasonable then. I think it works. Oh no, in Rust there isn't any size promotion. You have to be very deliberate about making sure the types match before you can do it, which is why when C allows multiplication of two different sizes, I immediately get the heebie-jeebies and I'm not sure what's going on. Okay, great. So I think we've got our item size and we've worked out our length. From that, we don't need these pieces anymore. So now, read only, I guess, is 1.
Yes.
Probably. Because it's really it's a Boolean, right? This, but
yep.
Is that because Boolean isn't at all in the C standard, or is it just that it's not in older C standards?
It's not in older C standards, and it has weird semantics.
Okay.
If you say something is bool and then you put something other than the exact bit representation of a true or false,
Yeah.
you get undefined behavior.
Okay. So you have
Right.
to be really careful
So,
when converting integers
well,
to
you don't have
Boolean.
to be careful in C because whenever you cast something to a bool, it gives you the correct bit pattern.
Yeah. Yeah.
But if you have an ABI and you have Rust right in your
Yeah.
memory, it's more complicated, right? So
Yeah.
I mean, we don't really have rules yet, but I would like to put in rules that we don't use bool in public API.
Yeah. It would be interesting to understand because I would think that the Rust interoperable or FFI developer or designers have come across this problem. I don't know
Uh,
actually what a Rust ball would
Probably.
try and write. It probably just tries to write
Yeah,
a one and a zero.
they're probably writing platform specific code anyway, and on all known platforms, the bit pattern for true is the same as one.
Yeah.
But the C standard allows other things, I think. It's yeah.
Yeah. Um, is the compiler allowed to assume that the rest of the bits in the bool are unused as well? Because in Rust, if you have a bool,
No.
um,
So
the compiler
the
knows it's only got two states, right? And it can use all the other bits to do whatever it likes.
yeah. Oh, and maybe yeah, I think so. I think there was some kind of optimization like that where the compiler reused other bits of the bool, or maybe checked for another bit of the bool and assumed that if it was one, then we have undefined behavior and it can do anything.
So
So uh, the most common thing compilers do when they detect undefined behavior, other than warn, is assume this code is unreachable and just optimize it all the way.
yeah, and then before you know it, nothing runs and you don't know why.
But
Um,
of course, they're free to wipe your disk or something like that.
yes, that would be the less helpful decision by the compiler. Just insert RMRF as a I don't know, a shell instruction or something.
Yeah.
Um,
Don't do
okay.
undefined behavior.
No. Yeah, we're very much taught not to in the Rust things way of thinking. Okay, great. So I think now
And you
having
have to return 0.
oh yeah. Well, should we just return PyBuffer fill infos 0 straight back out? Or I guess
Yeah,
we
you should check the return value from PyBuffer.
so
Oh,
so for
yeah,
the
just
moment we
return.
could just do this then, right? And then if we need to do stuff afterwards,
Uh,
oh no, because we
we
need to
do
set the
need to
item
do stuff
size.
afterwards.
Yes.
Yeah. So just store
Uh,
that.
so we have to do.
Oh, just store it
Oh,
and return it
yeah,
afterwards.
yeah. So and then to check this thing, it's probably cleaner if we uh, what do something like this. Is there a convention for naming this kind of error?
Several. Just as helpful as no convention.
Probably best to not check for zero, isn't
It's
it?
better to put less than 0 here.
Less than zero? Is that just more efficient? Or
Uh, it's more conventional, I guess.
okay. Um, like that.
Right.
Okay, and then so then we thought that we needed to set the item size afterwards, right? Oh, which Copilot's even even predicted for us. Thank you very
Wow.
much. Um,
Somebody else does that on GitHub.
quite possibly. Um, right. Okay. So I think that might be interesting to then play with and see how it works. But we're going to need to fill the release first, which
Which doesn't
oh
actually have to do anything.
let's think about that. Does it not? Does it need to? Does it need to decrement the reference count or anything like that, or is that
So
done
the
properly?
reference count is managed automatically. So maybe just check the implementation of the fill info if it increments the ref count. but
Oh,
yeah, I think it does.
yes, it calls X new ref.
Yeah.
So that's okay.
And decrementing is handled by
I thought it might be PyBuffer
Python
release.
itself. You don't. Yeah, if the only thing you need is decrementing the ref count, then you don't need to implement the release buffers.
Yeah,
At all.
because it's handled in PyBuffer release. Oh, interesting. Yes, and I see what you mean because it's not like this errors if you don't implement release buffer. It just doesn't
Yes.
do it. So
Yep.
for the moment, while our release buffer is boring, we can just comment this out and
Comment that as well.
And is it guaranteed then that it's going to be 0 initialized?
Yes. It's a static structure, so yes, it's 0 initialized.
Okay, cool. Oh, so if this was a stack structure, it wouldn't be guaranteed.
Yep.
Okay, cool.
The same thing happens with the type definition right below that, and you can put a comma there. That's fine.
I'm a bit confused why my editor's shouting at me, but maybe it's just being slow. I think we'll assume that squiggly is not a problem until we hit a compile error. Okay, sorry.
The iType object has some extra fields at the end.
Mm-hmm.
I kind of add those as we go along.
Oh,
And
new
yeah,
things?
those are all. Yeah, there are some things below that. They're just set to 0.
Oh, okay. And we don't need to add those now, is what you're saying, because they're set to 0 by the fact that it's a static.
Exactly.
Yeah. Okay, great. So let's try and build this, I guess. I think I've still got a good configure. No, it's configured again for me, but I think it just did the debug build.
So if the configure script changes, it'll reconfigure.
Okay, that makes sense. I think last time when we were playing around with CPython as well, I also hit a case where I can't remember exactly what the details, but there was something that had changed enough in the configuration that it didn't like the build at all. And I think you told me to make clean. So we might hit that yet.
So there's a flag for configure called cached or -C, where it will cache all of these results that it's computing right now and make future configures faster. Something's wrong. I've used variable length.
Oh, really? That doesn't seem to make sense, but what did we write? Oh, we've just we left the get length call rather than passing length. So that would definitely be a bug. And then the other thing that it's hung up on. Oh, do we need
Unicode as buffer, Unicode get buffer. Where are you?
It doesn't like my syntax here for some reason.
Wait, no, that's not the right
1755. It says it's expected equals here.
Oh. Yeah.
Maybe it needs that. Is that because we're using this dotted initial No.
No, it's the same with the type.
Okay.
So that's initializing a variable.
Okay. In Rust you don't type the equals. You just do you do it you do it the other way around. It'd be something more like this. Yeah. I guess. So you do have an equals, but not next to the type. So okay, fine. That works. Cool. Let's go again. Hopefully we'll be quick enough to compile. I guess because it reconfigured, we're rebuilding the whole interpreter here.
Yes.
And so, great, there we are. And I'm trying to think how to test this. There's a module called test C.
Well, try to take a memory view of a string now.
Ooh. Oh, yeah, okay. We've got a new way to deal with strings. So we could do and so it's just memory view, isn't it? It's built in just right there, I think.
Yeah.
Yeah.
Ooh, nice. Convert that into bytes.
No other Python interpreter in the world does this, right? We've got a very, very unique behavior here.
Convert it to
Yes.
bytes.
Yeah. And then that should pull them straight out, right? Cool.
There we go. And now try with emoji.
Yes. And then because what we should find with an emoji is that because we should probably just talk to that a little bit more. We've got those different kinds, right? For those following along on stream. And it's the point is that we can only fit in this like single byte encoding Unicode code points which are less than value 256. And so if they're that or larger, then they're going to end up being in the 2 byte or 4 byte kind. So yeah, let's put in an emoji. There we go. Let's just do a few. I'm clicking around. I seem to have sufficiently upset VS Code's terminal there, so it'd be very interesting to see what we get. By the way, that's right at the bottom of the screen. I don't know if I can somehow pad that upwards, or is it legible, just low for everybody watching?
It's fine on YouTube.
Yeah, I think it looks okay. It's just right near the bottom. That's fine. Okay, cool. So there's a string with a bunch of emoji. Print's okay. I don't even know why the heart and the rocket are overlapping so horribly. But there we go. So now we should be able to take a memory view of this one as well.
So the Unicode standard doesn't specify how wide a character should be when printed out on the terminal.
Yeah.
So there are third-party databases that are never in sync with actual
Unicode.
Yeah.
I briefly encountered this. Once upon a time, I was trying to help bring the Alacrity terminal to Windows, actually. It's a Rust-based terminal emulator. Because at the time it was before Windows Terminal had really come along and become a great product. And so I was sort of trying to be like, I just really don't want to use command.exe. And yeah, I had to briefly encounter all of that and just like, that's a problem I can't solve right now. I'm trying to capture the wrong string here on, so there we go, that's going to work. So if we take the bytes of this one, what we should find is that it's going to come up with, yeah, something a lot less meaningful. And I'm trying to think. And the interesting thing, I guess, as well, is that if we made a third string, which is a bunch of emojis with like hello world at the beginning, I guess what we'll see is we'll get that same wider encoding.
A bunch of zeros in it. Yep, there it is. H000, E000, L000. Yep.
Oh yeah, I'm just really struggling to read. There we are. So it's H, and then we've got 3 bytes of nulls. So that means that we must have hit 4-byte kind, right here.
Yep.
That we've got four bytes per character, and so it's E 3 null bytes, and then L 3 null bytes because each character is taking 4 bytes up in this encoding. All right, cool. Okay, so where do we go from here? Now we can turn this. We have 2 steps really, I guess. There's one is to turn this into an API where you request the encoding you want. Is I guess the first step we want to go for next.
Unless you're fine with an API that just gives you
buffer like
something
this,
you can borrow directly, and it actually includes the description.
You mean like this?
So try. I don't know what the memory view object attributes are. Can you get at it from Python?
You can probably get things like len, I would guess. Yeah, it has the item size. Has
nice.
What else do we need? That's it, probably, isn't it?
That's it. Yeah.
Does it give us like?
Need.
It gives us the inner string actually as well, which is quite cute. So okay, cool. And then so the downside I think of this result though is I think the point you were making about coupling to particular encoding forms, right? That as this currently works, downstream code would ask for the buffer from the string. It would get a buffer now, which is quite neat. But downstream code would then have to handle the different possible encodings of that string, which is sort of doable when they're fixed sizes like this. If it was UTF-8, or who knows if someone will come up with a different encoding in the far future, then those would have to be handled by downstream code, and
Right.
that's
Well, that
harder,
probably
right?
means that the get buffer would need to start failing
Uh,
for some strings. Because I mean, if you have UTF-8, the item size would have to be 1. It would have to be in bytes, and it
yes.
would be undistinguishable from Latin 1 or ASCII.
Uh, yes. Yes. So this API isn't enough to distinguish other string encodings. So that would be a reason to have something that's not a PyBuffer,
Well,
right?
something that doesn't use the TP get buffers, something where you can't just use memory view on the string, but you have to call a separate CAPI function to get the buffer.
Um,
So you can pass
so
in the flag and say, I want 4 byte per character string.
yes, and it wouldn't, and then we wouldn't be able to call memory view on a string like we just did in this interpreter here,
Right.
because the get buffer
Um,
wouldn't work. But for
I mean, this is
code,
a cute feature. I'm not sure. I'm not sure I wanted it. There's probably a reason why it wasn't added to strings.
I think it's probably for exactly the same reason we're talking about, right? That this is not only is this like giving C API readers the opportunity to stare into strings, but we're letting the whole Python ecosystem go, aha, this is what's in this string. And
Yeah,
I'm sure that people will do
you
horrible
should
things with
really
that.
call encode rather than looking on the
Yeah,
memory itself.
absolutely. Yes, you're right. It gives people far too cute an idea that they can just do like bytes memory view S like we've got up here and get exactly what they want. And really, I mean, you're right. The much better thing to do is obviously if we do S3 encode, that's going to default to UTF-8 encoding, right? Which is a much more reasonable, well, for some definition of reasonable, it's at least a portable, reliable thing.
Yeah.
um,
And I'm sure there are CPython developers that would disagree with me and say, we're never going to add another string representation. So that's a bit of my personal opinion in all of this.
uh, I, I see. So I guess then the question still remains like, do we try and turn this on its head then? And as we were saying at the start of the stream, we wanted to have the API say which encoding it wants, so that
Yeah.
we can like do that allocation on demand. And should we work towards that then? See how
Yeah,
that feels?
I still prefer that, so I would work toward that.
Mm-hmm. Okay, let's tuck away our terminal and turn this around then. So,
Works, put it in Git.
oh, we should commit this, send it. Fair enough. Um, let's just. I'll just do that for the moment and send it out to my fork, and then we can figure out. I guess we're probably going to build off this branch as another commit, to be honest. But we can.
Yeah.
We've got that pushed now at least. Okay, so the next step then is to have a go at. I guess we change this into a CAPI. So rather than giving this buffer, well, I
But we
guess
will still need the release buffer.
we will eventually.
So
We
we'll now,
could start by keeping the problem simple and just failing if it's not the current encoding of the string would at least get us the first implementation, right?
that's a good first step.
So this time I guess we will add an API in here, presumably at the
So
bottom.
where is that?
I'm just
That's directly in include. Oh, that's an include CPython,
yeah,
right?
include CPython. So I
So
guess we
when
have
you're adding it here, you're not adding it to the limited API.
yes, which would be the right first step at least, right?
Yeah, I guess yes.
Um, so this wouldn't be static. It would be an
So
int
this would be
for the return.
PyAPI func.
Yes, because it is
So
exported as a symbol.
yeah, that's some
Um,
macro magic for different compilers and linkers to export the symbol.
yeah, it's about saying whether it appears in the binary, right, at the linker level. It's
Yeah.
and there's no standard. Or why is there no consistency? Is it just because uh
Well, that's a feature compilers and linkers have added over the years. I think it's quite recent in GCC,
hmm.
and the Microsoft compiler had it for much longer, but I could be wrong.
And before that you couldn't specify linkage? Surely there must have been something. Or was it just this particular form didn't work?
Well, if the function is static, then it's not visible,
Okay, okay.
but then it's only visible in one C file. Also, the C standard doesn't concern itself with linking, really.
Okay. So compilers kind of had to make their own decisions as to how that would work.
Yeah.
Hmm. Okay.
I think there were linker scripts and manifests and stuff like that to tell uh, the linker what to do.
Okay.
But yeah, I don't really know the history here.
Either way, it's just hidden behind a macro now, and we just move on.
Yeah.
Cool. So now some recent APIs have been started being called PyOnStable prefixed or whatever.
So I wouldn't name it Python stable because we want it to be stable.
Hmm. I'm going to just come up with the name. We can bike shed this a lot later, but I'm going to go for get encoded buffer. Maybe.
Or maybe just get buffer.
And you think that asking for the code or the kind is okay? Because I guess what we're going to have is um, are there any flags that are reasonable?
Yeah, we need to
Let's jump back
put
to
the
the
kind
browser.
there.
We need kind. You're right.
The
I
kind
just was
of
going
flag.
to quickly think these flags that exist. There is only iBuff format. Interesting. Alt-terminate string, deciding the contents of a single item. Oh, so that's telling you the width of the characters or what you want in struct syntax. That's probably not relevant. And then the other one is writable, which we would never have. So I guess we don't need flags
Yeah,
um, in our header here. So we just take it's an int, is it kind? I think it is in other places.
yeah. So that would be a C enum if we were using C, but enums are notoriously hard to use for other languages, so it's just int.
So enums are okay on the Rust side actually. There are some
So the size of an enum is implementation dependent.
mhm.
It's probably part of the platform ABI, so it's specified somewhere, but technically it depends on the compiler you use.
Yes. And so
And of course, Rust has ABI binding generators that handle that. Those would be all uppercase by convention. Uh,
oh, okay.
so
But
yes,
I guess
Rust can figure it out, but needs to use some magic.
yeah, for Rust you basically have to stick this repr C on the top and then it says, "Hey, I want this to be compatible with a C enum."
Yeah.
And but I guess your point is that
And
other languages might have even more horrible times trying to make that work.
yeah, I mean the C standard doesn't say how big the enum will be. In newer C standards, I think it's C23, you can use the base type, like say this enum is an N64.
Okay.
In C++, you can do that, but the standard we use doesn't allow you to say that. So that's probably specified in some platform ABI
Hmm.
documents for individual platforms, and uh, of course, compilers can't change that. So you can write code that has a lookup table for all the platforms, which is probably what Rust binding generators do. But
Yes.
it's just more trouble than it's worth. So we use int.
Well, Rust actually, I mean, it uses LLVM for the compile, so I don't know whether Rust can hand off that work to LLVM there.
Well,
Maybe.
LLVM needs to be compatible with other compilers on the platform anyway.
Yes. So, and because LLVM can be used for C code as well, right? Clang. And so
Right.
is using LLVM as a backend. So I don't know. I guess my thought there was whether Rust doesn't actually solve the C compatible enum problem, but maybe it just goes in the
Oh,
LLVM IR. Hey, here's the C compatible enum. Do something with it. I don't know. Maybe it has to at the higher level first.
Rust supports a much more limited set of architectures than C,
Yes.
and it's a countable set, so it might just have an if ladder
Yeah,
for all the platforms there.
it's quite possible. Um, okay. So we've set up our definition for the symbol, which we put in the header file here.
Yep.
I've just seen a comment from Ethan, by the way. This is very interesting. I'm glad that you're enjoying the stream, Ethan. Cool. So yeah, we've got the symbol ready. So now we have to go actually put the implementation of this in our file here. So this is where we can, I guess, start manipulating the implementation that we've already got down
Right.
here. We might be able to even flags is presumably just going to be 0.
Ooh, well, that was some editor magic. Did you just copy and paste everything?
I just copy pasted everything. Yeah, that wasn't Copilot. That was me.
I think what this function needs to do is, for the first step, is check that the kind matches and then
Yes.
call that other function.
Uh, 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 oh, that's a clever way of doing it. Why was I not going to do that? I was not going to do that only because I assume that um, as soon as we start trying to do the allocation path,
Yeah.
then it all
Well,
gets
we're getting
horrible.
rid of the Unicode get buffer function anyway, so.
Yeah. So, but I like what you're thinking. So we could do exactly that, right? We could do if kind is not equal to the current code kind. We don't really need to do anything. We don't really care there because we're about to change that, but that's just for validity for the moment.
Yeah.
Uh,
Subspace kind there.
so now that's okay. And I guess flags can be 0. I don't know why it doesn't like that. And we can get rid of this one now. I'll find out why. I don't know what I've done here that's made it's unhappy. This is obvious enough now. We have no buffer methods at all at the moment.
And you should put it as 0 there. According to C standard, you cannot have an empty structure.
Okay, so we need this
For some
instead.
reason.
So we have to do that. That's fine. Okay, well, let's just try and run this and see why it's not building or not liking it. Or maybe it will be fine.
Yeah,
Oh,
case kind there.
and then 1473 doesn't like 43 doesn't like this. You can have a
View
trailing comma,
of
right?
read-only.
Oh, too many arguments. Can you not have a trailing comma? Oh, what?
Oh, probably you can't. That might be it.
So you can have a trailing comma on the struct initializers, but not in function calls. Maybe for historical reasons, I guess.
Probably.
Okay.
Yeah, and usually it put the ending parentheses on the same line as the last argument, which
Oh, you tend to do like
people,
this.
yeah,
Okay.
doesn't look very modern.
I'll go with this just because it's closer to what I normally write. But if it needs to be changed in review, then we can do that. Okay, so now we've built this API, but we actually don't have any way to call it yet. So
Exactly.
we didn't get very far here. I'm trying to think what a cool way to test this would be.
So one way is to use C types, but you probably don't want to go there. So now you would go into the test module,
Yes, I've seen this
test
module
C
before.
API, and just write a Python function that wraps this. So test C API is nowadays a directory, and whatever wasn't moved to the directory yet is in this test C API.c. So in
Okay,
module, there's a C API
right. So
slash
we can find
ring or
Unicode, hopefully. Great. And we don't need header files here? Or do we?
yeah, we do. Well, yeah, we look at parts.h. Parts.h. Yeah.
Oh,
So
okay.
it only lists the init functions.
Yes. So what's going to presumably be happening then if we jump to the Unicode one is that we've got a
So that
whole
already
bunch
has.
of functions we've added here. And then if we jump to, there must be this init Unicode, or what was it called? Init underscore Unicode,
It should be at the very end.
which is adding a whole bunch of methods,
Yeah.
which are all
So all of
defined.
these C files in this directory combine to make a single Python extension module.
Yeah, and we can call this. Is this actually shipped in production Python, or is it only in locally
That
built?
depends on your distribution.
Okay, so you this might work, right? But you shouldn't really be doing anything from this because it's the CPython's internal test structures rather than anything that
Yeah. So if
is
you ever
intended to be
need
exposed.
a segfault from Python, there's a test CPI function for that.
That's a good way of thinking about it. Um, I'm just trying to pick one. That's presumably going to be invalid if we just put something that's not Unicode or UCS4 in it. Oh. Look it up. Oh. We're going to get hints as to what they are? No.
No.
I won't even try to call this. Never mind.
There are probably some test flags, should I check for errors? Should I, whatever?
Yeah, that makes sense. Okay, but so we can add a new function to this module to call our new API. So I guess we'll just find, I'm guessing there's no good ordering here. Well,
Just check it at the end.
test string from format. Okay, so we'll have it'll be a static linkage, I guess, as you discussed. Unicode get buffer. And that's positional arguments only. That's probably fine. We don't need any, and we can just probably return a memory view, right? So actually, Copilot looks like it's done quite an amazing job with this.
Whoa. Okay. So what's it doing?
um,
Unicode view PyBuff simple
so it's never used self.
parse tuple.
Oh, that looks mad. That makes no sense at all. I think we can just
I just
assume that
remove
args is.
that thing.
What's the best way to enforce empty arguments? I guess this
Uh,
past tuple is the way, right? But
so just remove the name args. Just put in PyObject star.
oh yeah,
I think there's a PyUnused macro. So if you get in trouble with compiler warnings, you can do that. But this should
okay.
work for most compilers, I guess.
And so this won't check what arguments you pass in at all, but that doesn't really.
Yeah. So
Oh, hang on. No, this isn't going to be
what does
quite right.
this do?
This isn't even the right.
So the first argument needs to be the module. So that's the self or module.
Yes.
And then the second argument would probably be the Unicode object. So there's several calling conventions, and you probably want the one where the second argument is the Unicode object. Passing in. But
What's
you
that?
also want the flags, right?
Oh, I see. Oh, yeah, we need the flags.
Let's use argument clinic.
Yes. So actually, argument clinic is cool, right? So I don't know how to use this particularly, but I'm keen to learn because I know it
Let's see
exists.
if it's already used in this file.
What am I searching for?
Argument clinic.
Oh.
And I guess it's not.
But while we're figuring out what to do, argument clinic is a way of generating the built-in functions, and where you basically say the types of the arguments that you want, right? And then argument clinic goes away and finds the best calling convention for that function, so that when we're listing it in all of these module definitions here, argument clinic's already solved that for us. I don't know.
So let's see if one's close by.
There's a lot of parallels between argument clinic and what Pyo3 actually does in its procedural macros, where when you've got things like PyMethods or PyFunction, you've just written a normal Rust function, but Pyo3 goes away and analyzes it and figures out how to turn it into a Python function object. It's kind of similar.
And it's also usually faster than the handwritten code for
yes, because it can do the most efficient thing, right? Where should I be trying to copy paste from?
So try long.c and the C API instead of unicode.c.
Long.c.
And there's clinic input. So this header needs to be put on top of the file, like here. So that just says which, no, the clinic input, the comment.
Yep.
The whole comment block. Yeah, like that.
Needs to go at the top of the file.
Top of the file, yes.
Okay, so we're adding superpowers to the whole file here.
It's just saying telling argument clinic that the module here is the C API.
Yeah.
Okay, go to long.c again and look for another clinic input.
So does argument clinic search the whole code base for these, basically?
Yeah.
Okay. So
this is probably not a good one. Try another one.
Okay.
Another one. I'm trying to find one with arguments. We don't have one like that. Oh, that's okay. So
yes.
yeah, there's one. Get that.
So we do this.
Put that above the function in unicode.c.
Can my IDE help me get back to where we were? Yes. No. Where are we? Okay, it didn't go anywhere. Let's just go back down. That's better. Great. And so this is hinting to Argument Clinic that we want to use it. And now,
So now call it test CAPI dot Unicode get buffer.
yes.
Arg, well, that should be the Unicode. So str, and then you want an int argument as well after that.
Yes, kind int like that.
Right. That should hopefully be it. And then run make clinic. Let's save it.
Okay. Oh, I see. Okay, so Argument Clinic doesn't run on every build. You have to explicitly invoke it.
Yes, and CI checks if you have run it.
Ah,
Right. So
that's
now
smart.
what it does, it did this to see by Unicode get buffer impl, which gives you C string, so car pointer, and a C integer. But we
Yeah,
actually want the Unicode object, so instead of str, do object.
yeah, that makes sense.
I could probably type check that as well for us, but maybe we want to test the behavior if you pass in an int to this API.
Yeah, probably we want to put that type check inside our new C API, right, back in Unicode object.c. Because it probably wouldn't be any good to call that with an integer, and I don't think it's justifiable to not type check for performance reasons over in that function.
Exactly.
So now we take away this definition, I guess.
And you start with the opening brace.
Mm-hmm.
And just for fun, you can look at unicode.c.h, I think it is, in a clinic subfolder here.
Okay, so yeah, Argument Clinic's gone and generated this for us. Lovely.
Right, so this is the actual .ca Unicode get buffer function that handles all the argument parsing, calls the impl function, and returns the value. And the other thing it should generate, maybe it's below that or above that or something like that, is a method definition. Oh,
this bit, yeah.
The define on top of that.
Okay, yeah, that's very handy. So then what we can do is we can take that, I follow, and then that is how we get the entry that we wanted to put into this array. So we just put it there. Presumably it had the braces, so it's just
And
like...
I think it also has the comma at the end.
Let's check.
It's evil.
I'm not sure I like that.
Yeah. You're not alone. But, well.
And we presumably have to include our clinic header. Clinic didn't do that manually for us, so I guess it is like this, right?
Yeah. I don't think I've ever added a new one, so...
I just saw that when we were looking at the long one, I'd spotted that we had this include here, and I was like, oh gosh, how are we going to go and create all that? So internally I was panicking, and then now when you showed me that the header was there, I was like, oh great, we can just pull that in. So that's okay.
Yeah, so clinic is just a Python script that reads the files and puts in...
There we go.
Yeah, it's a very complicated parser thing that generates C code. Very optimized C code, so not for the faint of heart, but...
This is actually increasingly true of Python, of the interpreter, isn't it? The Python interpreter is itself C code that is built from Python code that generated that C. Because there's loads of this sort of stuff around in the CPython repository now, isn't there?
More and more of it, yeah.
So...
And I'm actually planning to do more of that with API definitions. So
yeah, I think it makes sense, right? Like I was just comparing Argument Clinic to like Pio3's procedural macros. Like I think Pio3 wouldn't make any sense without them. So like making C, like, what's the word I'm looking for? Dry, or like, yeah, probably dry is a good way of summarizing it. Like, you know, not having to repeat a load of boilerplate and get the efficient results just out of the bat by doing this makes sense to me.
So yeah, my plan is, we have a lot of discussions in the CAPI working group about should we type check the input for CAPI functions, or or should we just assume that they have the correct type? Should they be typed at the C level, or should you do just PyObject star everywhere and stuff like that? And my preferred solution would be to generate all those details, right? To have a script that reads some kind of description and generates API with those details for you. And then, of course, you could generate Rust API as well. It's just different text.
Yeah, that sounds like good fun. I would gladly, if we could just borrow those definitions straight from CPython, it would be very convenient.
Exactly.
So just to elaborate, just on that point you meant about like whether to check types or not, in the APIs for the viewers on stream. I think what Peter's meaning by that is like if we take this just arbitrary definition of this C API function here, right? It's taking PyDict set default, and it's taking 3 PyObject pointers. So none of these are actually like typed as PyDict, and so I guess the question is whether PyDict set default should be checking that all those are the right types, or making the assumption that the user has passed in the right types. Is that a fair description, or is there more nuance than that?
And of course, currently it should check, but that's not the best thing to do for performance.
Yes.
So usually when we have, for on line 55, the PyDict get size,
yeah,
that just has a static, that has an assert which only works for debug builds.
Yes.
So the macros assume that you know what you're doing,
yeah.
generally, but the actual API functions should do type checking. Not all do, but
I think it generally makes sense to do so. Like, it's not like type checking, especially for things that are really core built-in types, is prohibitively expensive.
Yeah, that's just a bit. We literally have a flag saying this is a dict subclass.
Yeah.
And if you want an exact dict and not a subclass, then that's a pointer comparison.
Yeah, it's probably not quite in this header, but might be in a nearby one. All right, let's jump back. That was a bit of a digression. So we've gone through Argument Clinic now to get our generated or function definition that's taking. We're not actually going to use module, are we? So can we delete the name? Let's see what happens. No, that's clinic generated code. I probably don't want to touch it.
Yeah.
So I guess we need to do.
How do you do unused in clinic? Let me try to find out.
Oh, I wonder if we go back to the long. Whether we can. So at least in this the long.c, it looks like nothing ever. Unless. Yeah, I don't think that the module was even referenced ever, so it just left it. So maybe let's not worry.
So what you do is in the argument clinic input. Oh, it's for the module.
Yeah.
Right.
But in long.c, it's not even those examples modules not even been referenced later in the body.
Okay, so that's fine.
We won't worry about that. And then we called it arg, so we'll live with arg now. We don't need any of this parsing anymore. Great. So we're calling our API function. If our API function errors, as we saw earlier, it will return, I think, -1, but so we check for less than 0, and we will return null. Oh, that's a little bit tidier than the braced form, which I wrote before. Is that preferred?
The braced form is definitely preferred.
Preferred to have braces.
Yes, do the braces.
Because otherwise the problem
extra line, a lot more peace of mind.
Yes, and again, I didn't even make the decision earlier because Rust doesn't give you the choice.
Good choice.
You can actually, you don't need the parentheses on the condition, but you do need the braces. I guess the point is that you have to have at least one of those two required. Otherwise, I think you probably get all sorts of ambiguity. And so I guess in C, the answer is that the parentheses are required.
Yes, it makes the parser much simpler, I assume,
Yeah.
which mattered when C was new.
Yeah. I mean, yeah, I wouldn't want to think too much about whether it would be possible to have a
Creating a
language with
parser
neither.
assembly.
Yeah. Okay. So we do that, and then my memory view from buffer is actually a real API, isn't it? So that's actually a valid way to get a memory view out, which is what we
Check the
need.
arguments. Yeah, control
It
buffer. Yeah,
looks like it's happy, so Copilot spat out something useful there. Let's build
Now,
it.
it's always good also to check the reference counting here. It should be correct. So by object get buffer just fills in a pre-allocated buffer, but
yes.
that buffer
Then carries a reference inside it, right? Because
yeah, but that pipe buffer is a struct
yes,
on stack, and you're
yes,
returning a pointer to that struct on the stack, which
seems a bit fun.
that yeah, the compiler will not like that. Should at least give you a warning.
This header requires PyBuild core. What have I done here?
Oh, what have you done? Oh, Clinic is only available for the internals.
Oh, so that's why it says PyBuild core. But so presumably that's been defined in long.c for it to use it.
Probably. Yeah.
Yeah.
Yeah, there it
Okay,
is.
so we can just nick that again and put that at the top.
It would be nice to have a public version of Argument Clinic, but
I think I've seen
nobody's agreed
suggestions
to that.
that's wanted because it it would help the whole ecosystem do something of that form. Why not? I did.
That's weird.
Well, maybe I
Should make again.
wonder. No, it's not in generated code. Huh. Will you forgive me if I just cheat and define PyBuild core for the moment? That's probably not the right way to do this.
Just cheat away. As long as you didn't put it in the pull request.
I guess I don't. So define PyBuild core only comes from pyport.h. Oh, so maybe the answer is that one of the other headers, which is being pulled in from this. So what have we got? Parts, util, and so parts is presumably already imported. Oh no, util is too.
That's weird.
I can't see any difference. I'm certain I saved. Let's just add a syntax error just to prove that I saved. Yep, that all blows up. It still doesn't like
you
it.
still get the error somewhere. Clinic Unicode. Huh. Yeah, just cheat for now.
Okay, yeah. No, that's not what I wanted to do.
Don't do this at home.
Why?
Like that suggestion.
So we'll need to fix that. I don't know where I've gone there. Okay. But now hopefully we should build. Test the public C API, not the internal C API.
Somebody's being really careful here. I know exactly who. Okay, the cheat won't work.
Okay. Maybe we need to go investigate.
Maybe.
No. The test API extension, public C API header files and include. Okay.
Oh, there it is. PyTest C API need internal API. It's probably needed for the clinic thing.
Doesn't look like it is, but it wasn't in long.c. But
Yeah, maybe the longs clinic code that's needed.
oh, you think in the what headers
I
does
don't
this
know.
include?
This has changed since I last looked at this.
Yes, so long.c.h doesn't include any other headers, whereas Unicode's has included PyCore mod support for check positional. Okay, what did we do wrong? Oh,
I don't think you did anything wrong. That's just the chicks are just too eager. But okay, let's work around this and get rid of the positionality of the arguments in the signature.
of course. We did that almost unintentionally, didn't we? That's that trailing forward slash
Yeah,
is
try
going to
without that.
enforce. So now we
Try
can
not
run make clinic again. Okay, and now we can go see.
make. Oh,
Uh,
there's still pyarg unpack keywords now.
so is the answer that using argument clinic requires the internal API at the moment, presumably for
Yeah,
efficiency reasons?
and
So
the test C API apparently now requires that you're not using the internal API, which
should we?
makes
Um,
sense. Just makes our life harder.
so I
Yeah, so don't use argument clinic and use pyarg unpack tuple or whatever it's called.
Yeah, I think what I'll do is, for the sake of time, I will go back, make it positional. I will run make clinic, and then let's go see what argument clinic generates for us. Steal that, and then undo all of our clinicy bits, and
Okay.
work out what's going on. So we need this function. Oh, we're going to need to copy all of this out. Oh, it was looking very nice. That's unfortunate.
Well, that won't really work, but try pyarg unpack tuple.
Oh yes. Oh, I see. So argument clinic's code is no good for us anyway. That's
Yeah.
very annoying. Okay. So pyarg, because this is still part of the core.
Yeah.
The internal API is a problem. Okay. So
Tuple, and you pass it
pyarg.
the arguments.
Oh, hang on though, because it's using fast call calling convention here.
Yeah, you just want the args.
But they're not as a tuple. There is an array of because it's using the fast
Yeah,
call.
you don't want the fast calling convention.
Yeah. So we can just do that one.
Arcs and no size. Yeah. And to unpack tuple, we'll take arcs and the name of the function, minimum and maximum, so 2,
Yeah.
and the addresses of whatever you want to fill in.
Ah, I see. So we want oh. Or should we use pass tuple and get the integer right out? We need a kind, right?
Okay, so unpack tuple will just unpack the tuple into objects, but yeah, parse tuple will, yeah, let you do a format.
And so is it something like this, colon O? I don't actually
I think
know
it's
these.
before the colon.
The other
Yeah,
way around.
before the colon, put in capital O for PyObject and I for int.
Okay, great. And so then this function then will take the tuple of arguments, check the first one's an object, and stick that in Unicode, I guess, would be probably a better name for it. And then the second argument is an integer, and it will convert it from a Python integer into a C integer, and then put it in kind.
And if it doesn't succeed, it sets a error and returns null. So here you want return null as well.
Yeah. And then we should be okay.
Good. Right, you don't need to return value.
Yep. So I think that that's...
Don't need the PyObject return value. But you do need to change the... Well, you do need to change the method def.
Yes. Up here. We probably don't want to define anymore, and we can start deleting out all this clinicky stuff as well.
Yep.
So let's probably copy this down into the array below, like everything else.
Yep.
So down here now. So it's Unicode get buffer. It is...
Don't need the cast, and it should be meth for arcs.
Yes.
And just remove the doc string.
Yep.
Right. Let's see if that works.
Yeah, it looks like we've broken naming convention, so I might just call it Unicode get buffer. We probably need to delete some argument clinicky stuff from up above first. Oops.
Yeah.
We can get rid of all of the stuff we tried to
That
fudge.
diversion didn't work, sorry.
That's totally fine. Right, let's give this another shot. Great. So now we should be there. So now we can see whether our new C API works as we expect.
That's not the right Python.
You're right. Thank you. Great. And so this new, we should now have this Unicode get buffer, which should take a string. And I guess kind will be 1. Oh, that's because that's not valid. Byte select object.
Byte select object. Huh?
Should I make clean?
No, you should look at the parsing.
Is it in the parsing?
Yeah, the py to arg parse tuple, I think.
Okay. Oh, you need a pipe between each. maybe I typed it in wrong.
Now the pipe says the rest of the arguments are optional, but the O should just give you a Pi object.
I'm going to go check our C API in case.
Oh, you used Pi object get buffer and not Pi Unicode get buffer. Because that's what the AI has in its database.
Yes, we let Copilot trick us. Right.
That definitely is a bytes-like object. There we go.
Say memory view before. So now let's see if we can go get our emojis out of shell history. And that's what we expect, right? We want to see 4.
Yep.
And now, great. So we've achieved that. And now I think the last step, I don't have a huge amount of time left, but it'd be nice to finish this last step if we can, is to...
Well, I would put this in Git.
Yeah.
So there are actually 2 steps. Well, more steps. So one step is to allocate new memory in case you ask for a different kind of buffer, which means freeing that memory in the release buffer.
Yes, and we can kind of get away with if we went for my slightly bad trick of allocating a new string, then we could avoid the memory bit. It might make maybe either's easier. We'll see. Okay. That's all our changes. So that's this. Okay. So let's go back to Unicode object, see, and look at our function. So what we mean is that here where we just failed, we instead want to allocate. That shouldn't be too bad, right? We can change this condition. There is a constraint, right, that it's not any old combination. We can only succeed if the target size is bigger than the current size, right?
Right.
So,
which means the full API will probably need some way to ask this the string which kinds it supports.
does it, or can we just fail?
Oh, in this function we can just fail, but we'll probably need a function like a new API function for the users to ask the string, hey, what can I use for kind? Or what's your preferred kind that I should pass in?
Yeah.
But this function can just fail.
Yeah, so for now we can just fail. I take your point. So there might be more work to follow up with. But what we can do then is...
But it's one nice thing about this 1 and 2 and 4 byte kind being the actual numbers is that it's a bit flag. You can order them together and say, I support all 3.
Yes. And oh, right. So it actually doesn't need to be that complicated. So then if we wanted to add more encodings, you just go for the next bit in the sequence.
Yeah.
Mm-hmm. Yep, that makes sense. So it's easy enough to do that. And then downstream code can decide, okay, I can call this one and not fail. And I guess you're right. Probably there could be a preferred kind as well, which is like an API to get the most efficient calling or choice. But okay, so for now, it would be cool to try and solve that case of let's allocate if we need to. So
I assume you have about 7 minutes.
Well, we can overrun maybe very slightly, but we'll try and keep this not too much further, I think. Yeah. So
maybe a good time to wrap up.
You think rather than try and do the allocation, save that for a future session?
I mean, Yeah, well, let's do the allocation, but we'll probably not have time to test it and show it off.
Yeah, I
Maybe
think.
let's do a future session. I mean,
Well,
there's
we might.
tests to write as well. There's
Oh yeah,
documentation. There's the pull
this is.
request, the discussion. It's far from done.
I agree. I think it's probably. Yeah, it's totally a long way from eligible. It's probably less interesting for viewers to see the tidying up and the discussion. I mean,
Yeah,
like we might come back and do some more later if there is another interesting piece. But I think let's try if we can just see if the allocation step works because we've
right.
got
Let's
the
go.
API hooked up. We can at least run it in the terminal very quickly and see what happens. So,
Works.
so let's see. I might keep things simpler and just do it for one size, maybe. I'm trying to think what a good way to do this is. So if we take the kind, we know the current kind. I guess we might want to split it out as a separate function, but for sake of simplicity, I'm tempted to.
Maybe.
So,
So I guess the most, I guess the easiest part
yeah,
here would be if somebody's asking for 4 bytes because we have a PyUnicode as UCS4. You have PyUnicode as UCS4 copy. So let's try that one first.
copy the string into the UCS. Oh, brilliant. Do we have other ones? No, because the other
I don't think
ones.
we do.
So let's think. Then, so that okay. Well, we could do that one, and that at least solves most of the problem. And then there's just a case of doing like a UCS2 copy or whatever. So, I think what's the best way to do this? Maybe
So inside this if, we
yes,
say if kind, if the requested kind is the 4-byte kind.
yeah. Oh yes. Then we don't need to check it. Oh yeah.
Then
So we don't
we
need
need
a
to
full
check
switch for now. We can just do
right.
if kind. 4-byte kind. Then we can have we're going to need to do an allocation. Do we
So the function allocates for us.
oh that's really nice. Cool.
Right. Yep. And we need to remember that that this needs to
So
this needs to be deallocated.
oh hang on. So we can have data equals that or and then where do you prefer spacing? That way around or the other way?
The other way.
Okay. And then so because this I assume is going to be such a quick operation, doesn't really matter. We might as well just set it once. Then here we can change to be that. And you're right, we need needs in dealloc equals 0.
And for
Here it needs to be
local
1.
variables, you can use bool.
Interesting. But we're going to save it into the structure, right? We're going to end up doing this, right?
Yes. And you need to cast it to a void pointer.
Like that.
Just like that, yeah.
Again, spacing. Do you prefer space or?
Whatever.
Okay, we'll go with that then.
I don't think Pep7 actually specifies that. Yeah,
just
nothing
change
about
the.
casts in Pep
So
7.
we need to change this to data now. And the final step is we're going to need to implement this release buffer.
No. So the function can fail. So PyUnicode, as you see, is for copy, can fail with memory errors. So in that case, you need to return -1.
Okay, so we need if like this.
Yeah, yeah. And check for any other returns. Oh, the big switch needs to be in an else, right?
Yes.
And so you need to. Oh, not in an else.
It might be nicer if it's the other way around, right?
Right.
If
Yeah, you need to. You still need the switch, but you need to switch on the requested kind. You need the switch in both cases.
I think I was going to, and then we can have another else. See if it makes sense when I finish typing it eventually. So if the kind is good, we get our implementation that we already had.
Right. Yeah, makes sense.
Item size is going to have to go up here as well. And then I guess here we can do something like that.
Yeah, maybe use str instead of Unicode in the human readable message.
Something like that, maybe. Okay.
Right.
So we've got it a bit that we don't need anymore. This is redundant. Great. So if it matches,
I set the item size as well.
yes, we need to set the item size in here. Might do it just like this. Okay. Great. So that's
good.
looking better.
There are no returns between the allocation and the final return. Oh, there is one. If res is less than 0.
So this is where
this is where the goto will come in. But for now, you can just say if needs dealloc, then call.
Is it PyMem3?
PyMem3.
Great. Yeah. And so we could instead have that goto jump for the error handling, but that's okay for now. Okay, great.
Right. And now we need release buffer.
So in here, I guess we can we do the same cast backwards? So it's if, do we use bracketed all like this? Maybe that's a bit too cryptic, and we should just name this. Or
again.
Like this. And it was called view in other places. So like that.
That looks good, yeah.
And cool, we need to add that back into our type object. And I think we're ready to compile.
Let's see what the error is.
No, we're good. We got this first time. Very nice.
All right, so, let's test it.
So what are we expecting to see? We're expecting to see that if we do this for a simple string, that's no different than what we had before. Now we should be able to pass 2 and get a failure. And if we pass 4, we get a success. Very nice. Where if we pull out the bytes, we get that long 4-byte encoding of hello world, as we talked about before. So that's looking like it works.
Yeah, and now if you exit Python, you should get an error. And you also shouldn't get a memory leak, which we'll test later.
Uh, oh, I see. If we forget this, do we get a warning that the allocation was never freed?
Uh, well,
What error were you
if you
expecting?
put this in tests and run in the ref leak finder mode,
Mhm.
or if you use Volgrind or something like that, then
Yeah.
that'll catch that for you.
Okay. Yeah, yeah, yeah. And so
But
that,
it does need automated tests, or well,
yes,
it's better with automated tests.
yes. All right. Cool. So I guess having gotten this far with the implementation, it's looking quite nice. Um, I guess the next steps will be to push this. It's probably no better than a draft PR at this point, but I can at least like put it up there, and then I think I'll get round to helping tidy this up. I think it's still
Right.
got a lot of
So
effort remaining, as you say.
I I recommend making it a pull request to your own repository,
Okay,
so you can then use the GitHub API on it and share it with whoever wants the link.
okay, but
But you won't get everybody in the world commenting on it.
that's quite a good idea. Okay, I'm happy to do that. Um, and then it might be helpful if you were just willing to like help me guide me through what pieces we think we need to add to it before it's CPython worthy. Um,
Send me the link.
yes, I'll get that done. Maybe off stream afterwards, just we're wrapping up. Um, let's do let's do it now, because then we can also put that link into stream chat for the people who've been following along at home. So this is allocate on demand for coding
I think that only leaves one case where we have a 1 byte string and we want
to
to
be
fill a 2 byte
bytes.
buffer.
I think you're right, because we've done 1 to 4 and 2 to 4, and 1, 2, 4 on their own succeed. 2 to
So
1
it's
and 4 to
2.
1 and 4 to 2 all fail here. So I didn't enumerate that in a consistent way, but I think I agree with you. And so that's probably as straightforward as having a PyUnicode as UCS2 copy internal kind of helper or something.
Yeah.
But yes, we can finish that
Probably need
off.
to find that internal thing, but could also write it from scratch.
Yes. Right, so let's go to my own fork of CPython then. I'm going to need to synchronize that. And then I'll do that. And let's fill out the rest later. Oh, hang on. Nope. I've just done that against CPython. Sorry. That's very annoying. There we are. I'll go explain what happened on the CPython repository in a moment, I guess. So that people don't just see that and get very confused. So that's where the code lives at the moment for the viewers at home. So, and so yeah, I guess the final thing that I'd be really curious to hear about is we obviously talked about that resource API as opposed to this as using this buffer structure, and having worked with this a bit more, what your feelings were on whether you think we should be proceeding to use with the buffer implementation for
Uh,
now, or whether
so
we
I think
should
the
be.
only reason for that resource API is that the structure that you pass around is simpler,
Yes, because it doesn't
which
have all that additional
yeah,
uh, metadata, and
that it's not self-describing, let's say.
yeah, which we don't strictly need in this case. But I mean, the downside is that we end up defining a new structure, right? I guess it's not that hard to change this implementation later to
Right.
do that if people want it. And it's more additional API surface being adding a resource type, right? Because it's
Exactly. Yeah.
so
It's
I guess
more
the
API to take care of, yes.
the main thing I can imagine that people might object to about using the buffer structure is that we've had to add release buffer to string. I don't know whether that's going to have like interesting implications, even though you can't get a buffer
I
from a
mean,
string in any
that
other way.
only gets called if you have a buffer with the string as its object.
Yeah,
And this is the only API that can give you that, so should be
shouldn't
fine.
mean anything. Okay, cool. Um, in which case, that's looking quite nice. Uh, I don't know how quickly I'll be able to manage to finish this off, but I will do my best. There's a lot of bits and pieces going on Python 3 side at the moment. We're like very, very close to a quite significant
There's
release.
absolutely no rush.
Well, when's 3.13's beta freeze?
Right, yeah, that's in a few months. So if you want it in 3.13, then uh,
Uh,
let's get the discussions underway.
yeah, I mean, it's not like this is a game changer if we don't get it in 3.13, right? Because the
Exactly. So
existing
the
stuff
thing is,
already has. But
if it doesn't make it into 3.13, 3.13's AP, like internal API, will pretty much be fixed, right? So you can continue using whatever
yeah,
hacks you already use,
yeah,
and then just switch to the new thing in 3.14, right? There,
yeah.
you
There's always next time. All
prioritize
right.
your family and your other projects.
Hmm. Yeah. Okay, great. I guess if anyone in chat has any quick questions before we wrap up, maybe we've got a couple minutes, but otherwise, thank you very much everybody for joining and viewing today. I hope you've enjoyed watching me and Peter work on this, and thank you in particular, obviously, to you, Peter, for spending your afternoon. I guess it's I think you're an hour ahead of me, so it's heading towards evening and dinner time now for you. Um, so spending your afternoon working with me on this, it's been good fun. I've really enjoyed this.
Thanks for having me. I think I can budget this as mentoring, so
Oh, perfect. Yes,
fine.
because you're a CPython developer in residence, right? And so
Yes.
your time gets accounted into the PSF's budget, is it?
Yeah, I'm paid by the PSF and sponsored by Bloomberg Engineering. Thank you for that.
Mm-hmm.
And I am supposed to do mentoring, and I think this uh, is not traditional mentoring because it's public, but should otherwise it's the same thing.
You're certainly helping me contribute something to CPython that makes the ecosystem hopefully just a little bit more robust. So
Right.
it
And
sort
hopefully
of
we're
seems
also
useful.
teaching lots of other people about the CAPI.
That's true. We've had obviously about I think it's been the numbers have been between 5 to 10 viewers at home, sort of following through the stream. But I think we might get a few more views of people who are curious later. So yeah, certainly gets to a wider audience that way too. All right, cool. It doesn't look like we've got any questions in chat this afternoon, so I guess this is probably a good moment to wrap it up there then. Thanks again. I will end the stream here now.